And first I want to share my screen. Okay, so there's a few, if you have questions, just come to office hours. I don't want to take up time in the regular class because we have so much to cover. Okay, so a couple of things. I graded quiz number 2, the in-class quiz number 2, which you took, let's see. Today's October 1st. So this is where we did it. It was called the second setup statics of particles quiz. So now you could resubmit it. Remember, all quizzes that are in person, you could resubmit to get back points. I'm really realizing I got to get some water. My voice is weird. So hang on a second. I'll be right back. Thanks. Okay, so we had one setup quiz already a couple weeks ago, and then last week we had our second setup quiz. So it's been graded now, so you could check out your grade and look at what the markups are, and then you could resubmit that quiz. And remember that I've scheduled interviews with almost all of you, and I've met with maybe a third of you already. And remember, that is a statics of particles problem. So even though the quiz is just the setting up part, the setup, remember, includes given and find, the table, and the free body diagram. The interview that you're doing with me is the given and find, the table, the free body diagram, and then we go ahead and do components and do the equilibrium equations for solutions. So just make sure that when you're coming to the interview, you remember that it's a statics of particles problem. So the resubmit is due on October 3rd. And again, for me, the easiest way is to actually look at the calendar. And the calendar shows where everything's due. So it's due in a couple of days. Okay. Okay, so that's one. I'm going to go back to the module now. I want to also remind you that those of you who are majoring in civil, architectural, structural, mechanical, aero, marine, this is the most important class that you're taking right now. And you are meeting 5 hours a week, 3 hours in lecture and 2 hours in lab, which means the amount of time you should be spending outside class is 2 to 3 times the amount of time in class. So you should be spending 10 to 15 hours outside of class on this, okay? So please make sure that you're spending enough time, okay? Free body diagrams are still tripping people up, especially in 3D. So you need to get better at drawing 3D free body diagrams. So that means open your textbook and just start drawing a bunch of them. If you want, you could come to office hours and just draw them all in front of me, and I could give you suggestions. But you need to get better at drawing those 3D free body diagrams. And remember, it is a free body diagram meaning that the point you're choosing is removed from the connections to the wall and you're drawing the forces. Some of you, I've noticed when you're drawing the 3D free body diagrams, you're just drawing the forces and the arrows and you're forgetting to put the distances or the angles. A free body diagram includes the positive X, Y, and Z axis, the lines with the arrows for the forces, with the forces labeled with either variables or the values, and you have to show the directions of those forces, which means if distances are given, draw the distances. If the angles are given, draw the angles. Okay? Okay. Any questions before we go on to today's topic? Okay. So today's topic is one of the two my favorite topics in statics. 3D right-hand roll. You want to exercise your hand because you're going to be spinning it in 3D. Okay? It's really fun. Okay? It might take you a while to get it, but you're going to get it and you're going to be fine with it. But to start out, it might be a little bit challenging. Okay. So what we're working on is I'm coming off the module. The problem is in the module. You can print it out if you want, but we're going to be working right on the sheet. So I am going to put the document camera on now. And here's the problem. Everybody see it okay? Thumbs up? Okay. So it says 3 forces are applied to a bar as shown in the figure. Determine the moment that the 3 forces cause about the X, Y, and Z axis. So we could look at point O, but we're really trying to determine what is the moment about point O, which means what is the moment that's going around the X axis through point O, what's the moment about the Y axis, and what's the moment about the Z axis point through point O. Okay? And we're going to use the right-hand rule. So the first force we're going to look at is the 150-pound force. So let me get some markers. And I'm going to draw my line of action of my 150-pound force. Okay? And I'm looking at the x-axis right now. And the x-axis goes out to here. So it might help you just as it helps me to draw the line of action and the line larger. So this moment in orange, you guys, which is the 150-pound force, creates a moment about X. And remember, when we talk about moment, we're talking about spin. So let's put our fingers, everybody put your fingers in the direction of the 150-pound force and put your palm towards the line or the point you're trying to find the moment about. Does it create a positive or negative moment about X? And let's, were you guys hearing me okay? Because I didn't have the earphones in.
Yeah, you're good.
Okay. All right, let's start with Isaac. Oh, and Isaac, by the way, I wasn't able to open up that second quiz of yours that you submitted. I don't know what's the matter with the file. So you have to resubmit it. So it's the second setup quiz.
I'll hang out after class to make sure I resubmit it properly.
Okay. So just resubmit it on the resubmit it. Email it to me.
Okay.
Okay. All right. So Isaac, we're starting with you. You put your fingers in the direction of the 150 and you put your palm towards X. Do you get a positive or negative moment about X?
Fingers in the direction and palm towards X. That is going to be a positive.
Okay. And how did you know it was positive? Which way was your thumb pointing?
Because my thumb was pointed towards me.
Right. It was pointed along the X axis, right? Okay.
Yeah.
So the moment, I'm going to start writing it in here. Moment about x-axis we determine is positive. And what's the absolute value? Isaac, I'll just have you continue. What's the absolute value of the force?
150.
150. And what's the absolute value of the perpendicular distance from the force to the line?
I can't read it under the orange, but it's whatever
Okay.
that is.
Okay, so it's 30.
30, gotcha.
Okay, so let's talk about that. And I'm going to do it up on the side. You guys, we know even though we're not doing this vectorially, we're doing it using right-hand rule. Is everybody with me? Look at me, or look at the paper. The moment is equal to r cross f. It's a cross product, which means this vector is perpendicular to this vector and this together. In this particular case, let's go on to Jack. Jack, what direction is this 150-pound force in? Maybe Jack's not here. Jason? Levi? Is it Levoy?
Lavoie, yeah.
Lavoy, thank you. Lavoy. The 150-pound force, what direction is it in?
Yeah, I'm squinting at your paper, but it's inscrutable to me what the axes are labeled. And can you scroll down as well?
Sure. Okay, hang on. This is the z-axis, this is the
Oh,
y-axis, and this is the x-axis. So what axis is it in?
it appears to be in the z-axis.
Okay, so I'm going back up here. The force is in the z. Jason Lee, what line am I trying to find a moment about? What axis?
X-axis.
X. So you guys, the 150-pound force is in the z-axis. The moment I'm trying to find is in the x-axis. So where is the perpendicular distance going to be, Jordan? If we're looking at force is in the z and the moment is in the x, what is perpendicular to the x and the z?
The y-axis?
Y-axis. So therefore, what Isaac said, that the perpendicular distance is 30 degrees from the 150 to the x.
Meters. Or inches.
No, it says inches. Inches. Okay, so let me say that again. The force is in the 150. The x, the moment I'm trying to find is about the x. The perpendicular distance is right here. And because the force is in the z and the moment is in the x, the perpendicular distance has to be in the y. So that is a way to check yourself to make sure you're choosing the right dimension. Okay? And this value, what does it come out to be? 3 times that, it's 4,500 plus inch pound. Okay, so now, Cody, is Cody here? Okay, Laura, we're now trying to find the moment about the y-axis. We're trying to find the moment about the y-axis. So when I'm trying to find the direction of my moment around the y-axis. I put my fingers in the direction of the force. I put my palm towards where the y-axis is. And does it create a positive or negative moment about y, Laura?
Negative.
Great, negative. Okay, what's the absolute value of the force?
150.
What's the absolute value of the perpendicular distance between the orange force and the pink axis?
16 inches.
Great. And how did you know that?
Because on the drawing, it has the magnitude of the distance.
Okay, and so it's perpendicular, right? In
Right.
this case, we're looking at the force is still in the z. The moment is about the y, so the perpendicular distance has to be in the x. And what does that turn out to be? 150 times 16, 240. It's negative 240 inch pound. Okay, and now we're looking at a different one. And Laura, next is Liam. Liam, Now we're trying to find the moment about the z-axis through point O. So looking at this force of 150, my first question is going to be, and it should have been in the other two, is does the 150-pound force create a moment about the z?
No.
How come?
It's in the Z direction already.
It's already in the z direction, which means the force is parallel to the line. A force cannot create a moment about a line. It can't cause this line to spin. Is everybody comfortable with that? Let's see, thumbs up,
Yes.
questions.
One more time, which line were
So
you?
we're trying to find the moment about, we're trying to find the moment about the z-axis due to this 150-pound force. The 150-pound force is parallel to the z-axis. So it cannot create a moment, and therefore what Liam said is correct. Okay, now we're going to the next force. We're going to the 250 now. So I am going to, with my Sharpie, just cross this out so we don't look at that one anymore. And now instead, we're looking at the 240-pound force, which is down here. Okay, so we're up to Luis. Luis, you're here, right?
Yeah, John.
Yeah, great. Okay, so we're looking at this force, which is 240 pounds. And the first question is, does this 140 pounds create a moment about the x-axis? It's below the x-axis. Does it create a moment?
It should create a moment.
Yes, it should, and it does. Okay, so now we find out, does it create a positive or a negative moment about x? So put your fingers in the direction of the force. Your right hand, put your fingers, fingers in the direction of the force, palm towards the point I'm finding, in this case, the line I'm finding a moment about. And does it create a positive or a negative moment about x?
I want to say positive.
Correct.
Really tricky.
Because your thumb, when you put your force in the direction of the force, when you put your fingers in the direction of the force and your palm towards the x-axis, it creates a positive spin about x. And then, Luis, what's the absolute value of the force?
240.
And what's the absolute value of the perpendicular distance?
I can't see it very well, but it looks like 150.
Okay, let's see. So this is a 150 pound up here. We're not using that
Okay.
anymore. So again, Luis, this force is in what direction?
And the Y?
Y. I'm trying to find the moment about the X, right?
Yeah.
So the perpendicular distance will be in what direction?
And the Y?
Let's say it again. The
In the Y?
force is in the Y.
Yeah.
The line I'm trying to find the moment about is the X. What is a perpendicular to both Y and X?
I can't see the value, but it looks like 30.
Is it this? It's
Isn't that in
this.
the Z?
It's this one where I'm circling right now.
That's not.
Because look, it's 9.
But that's not in the Z. Sorry, I can't
It
see.
isn't. It is in the Z. Here's Z. Can you see this?
Yeah, yeah.
The Z, it's parallel to the Z. It's in the Z. So what's happening is this orange force lies underneath this green line, and it's 9 inches.
Oh, okay.
Okay, don't get stressed out. The next one you're going to get right. It takes a while to see it in 3D. The force is in the Y, and it lies underneath the X. The X is in the X. So the perpendicular distance has to be the Z, which is 9 inches.
Okay.
Okay? And 240 times 9 is 2160 inch pound. Okay, So now we're up to Mackenzie. Mackenzie, where are you?
I'm here.
Okay, so we're looking at the same force, right? We're still looking at the 240, but now we're trying to find the moment about the y. So maybe I should color these. Y, Z, 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 and green. X, X, X. So we're trying to find the moment about the y-axis, which is the pink, and we're looking at the 240 force.
Okay, so
Does,
isn't it 0 because it's
It-
parallel to the
correct,
y-axis?
it's 0 because the force is parallel to the line. Excellent. Okay, next, Marcine. Now we're looking at the 240 force creating a moment about the z-axis.
Yeah.
So does the 240 force create a moment about the z-axis?
Yes.
Great, it does. And is it positive or negative? Fingers go in the direction of the force, palm goes towards z, and where's your thumb going?
It's towards me, so positive.
Positive. It should be up, right?
Yeah.
Your fingers go in the direction of the force, palm goes towards the z, and my thumb is pointing in the positive z direction. It's positive. And what's the absolute value of the force?
240.
Great. And what's the absolute value of the perpendicular distance?
Is it 16?
16. Great. Now why? Let's see. The force is in which direction?
Along the y-axis.
It's in the y. We're trying to find the moment about the z. So that means the vector that's perpendicular to y and z is going to be x. And look, here's the x-axis. Parallel to the x-axis is the 16. 240 times 16 is plus, and you don't have to write the plus, inch pound. Okay, now we're going to the next one. We're looking at the next force now. I guess I'm using the same color again. 300, where's the 300? Ah, it's over here. Okay, 300. Isn't this fun?
Definitely is.
Okay, fun. All right, so this one is the 300-pound force. And we are, Maria. So the 300-pound force is in what direction, Maria?
The x direction.
Correct. Does it create a moment about x?
No,
Why not?
because it's parallel to.
Parallel. Great. Okay, Matthew. Is Matthew here? Myra? Oh, Matthew, you are
Yes.
here. Great. Awesome. We'll go back to Matthew. Thank you. Sometimes I can't see the chat because I'm doing all this stuff. All right, so Matthew, now we're still looking at this force of 300 pounds that's in the x. Does it create a moment about the y-axis? Okay, I'm looking for the chat. No, correct, it does not. Why does the force of 300 pounds not create a moment about the y-axis? Matthew. Okay, the vectors are 2D together, yes. Or another thing we could say is it intersects, right? Doesn't this force intersect the y-axis? And if the force intersects the y-axis, there's no perpendicular distance. So I'm going to use this symbol to mean intersect. The force intersects the line. Great. Okay, Myra, last one. We have the force of 300 pounds still. We're trying to find the moment about z. Does this force create a moment or a spin around z?
Yes.
Yes. And does it create a positive or a negative moment about Z? Fingers go in the direction of the force, palm goes towards the line Z. Which way is your
Negative.
thumb? Negative, correct. And what's the absolute value of the force?
300.
300 pounds. And the 300 pounds is in what direction?
In the positive X.
It's in the X direction. Doesn't matter positive or negative, right? Because we're taking absolute value. It's in the X direction and the Z is in the Z. So what's the perpendicular distance that we want?
In the Y, but I can't see it. It's
Right, it's here, right?
yeah.
30. Excellent. Okay, so we just determined now the moments that each of these forces created on that point O, and we had done it using right-hand rule. So if I want to know the total amount of moment that's created about O, Miles, you're here? Miles? Okay, Peter, you here?
Yes, I'm here.
Okay, Peter, I want to know the total amount of moment that's created on point O due to these three forces. What do I do?
Take the summation.
Yeah, I add them all up. So there's a 4,500x and there's a 2160. So that's 6660. 6660I, and it's all positive. The Y, there's a negative 24, only negative 2400J. And then the Z is 38 minus a 90, so that's 67, somebody check my math, minus K. Let me just write this over here. Inch pound. Somebody else get the same numbers as me?
I think it should be 5160. K.
51?
Yeah. Yeah, 5160 for 3840 minus 9,000.
Oh yeah, thank you. Okay, so, and what have, Tim, you're getting the hard question. Tim, for moments, how have we represented, remember there are three ways to represent a force vector, right? Vector form, magnitude and unit vector, and magnitude and direction angle. For the moment homeworks you've done so far, what have you now noticed is the way you represent moments?
In vector form, and then in
And
vector form, and then also in magnitude and direction angles.
correct. So magnitude, the magnitude of O would be 6,600 squared plus 6,600 squared plus 2,400 squared plus 5,160 squared equals under the radical 8714.7 inch pound. And then how would you, Tony?
Yeah.
How would you calculate the X direction angle?
You would take the inverse cosine of, I can't see the numbers.
Right.
The inverse cosine of each one of the components divided by the magnitude.
Great. So to find the inverse, in order to find theta X, the direction angle in the X, it's the inverse cosine times whatever the moment in the X direction is divided by the moment, the magnitude of the moment, and we would get those values.
Mm-hmm.
Okay, and I don't think it's necessary to calculate them right now because you know how to do that already. Once you calculate those direction angles, what are the two checks? Victoria.
Yes.
So once you calculate the direction angles for these moments, what are the two different checks you're going to do on the direction angles?
You check the cosine squared of each component and you add them up, and then they're
Great.
equal to 1.
So
And
the
then-
checks for the direction angles are the cosine squared function equals, you know, dot, dot, dot equals 1. And what's the other?
And the acute and obtuse angles.
Great. Right, great.
Joanne?
Yes, Amani.
It's the magnitude
Like
is
yeah, is it wrong?
yeah, it's 8760.2.
Did somebody else get, what did, yeah, Tim, I see your face, you're nodding. So 8760?
Mm-hmm, 0.2.
Thank you. We're back up to Adam. Adam, are you here? Okay, Amani. Why am I making everybody do checks all the time? Is it just because I'm a pain in the ass?
No. Well,
Maybe.
Amani.
Okay, why else?
it's so we can check if our moment's going in the right way.
Right. You want to check. I mean, you know, you're designing a bridge or a building or a shuttle or a pole or whatever. You got to check yourself. You know, you're learning not just to do statics problems. Some of these problems you could probably do in your head. But there's two important things that I'm teaching you. One, check yourself. You want to make sure that you're checking. The last thing you want to do is design something, not check it, and it falls over. Second, the other thing I'm teaching is I want you to solve things methodically, step by step, because your bosses and your peers are going to be checking your work. You don't want your work to look like shit. You want your work to be neat and methodical so that everybody understands what you're doing and they appreciate your work. So you in this class are not just learning how to do statics. You are learning how to present your work correctly. Well, not correctly, in a methodical way. Your boss might have a different way that he or she wants you to present your work. But for now, I'm your boss. So I'm setting the methodical way that I want you to do it. So when I check it or another student looks at your work, they can understand you. So this is all really about professionalism, how to present your work and how to check your work, in addition to learning statics, okay? All right, going back to this problem, how do you guys feel about this 3D right-hand rule so far? Are you feeling okay? Okay, let's do another problem, a little more complicated because it's not all drawn out for you already.
Joanne, I have a quick
I made the
question.
right hand because my actual right hand was getting overstretched.
Okay, David?
Just to clarify, the last thing we said was acute obtuse angle check, but that's similar, if not the same, as the we've been saying positive negative check, and that's the idea that what if it's an acute angle, it's in the positive direction, and if it's an obtuse angle, it's in the negative direction.
Right, correct.
Okay, thanks.
So you could write positive, negative, but you're not, when you get, if you're checking your angle, you're not getting a positive or negative angle, right? You're getting an acute or an obtuse angle. So in this case, we should get an acute angle for theta x, and we should get an obtuse angle for theta y and theta z because they're negatives. Okay? Okay, so let's go to the next problem. And again, you're noticing that I'm doing the same problems I'm having you redo the same homework problems in different ways. And in class, we're doing the same class problems in different ways. Okay, so let me go back and take a look at this thing, this problem. So I'm going back to this problem and I want to find out what the forces were. So let me look at it. So the force AB the value we had calculated was 400I plus 500J minus 360K, and it's in newtons. Okay? And what I want you to do is I want you to find the moment about point C, which we already found. And let's just go back and see what that number was so that we can actually check it when we get there, when we calculate it again. So I'm looking. It was, so this was, we got 180. We did this vectorially. And we got negative 180I plus 36J minus 150K Newton meters. Okay, so I'm giving you what the force is. The first thing I want you to do, you guys probably haven't printed the sheet out, huh? Okay, well, oh well. First I'm gonna draw my corner of my box here so I could see my box more clearly. And now I'm gonna draw my forces. And this is practice. I want you to watch me. This is practice for you again, because 3D, still people are struggling. So I have a 400 value for my force, and it's going in the positive X. So first thing I do is I take a look at the axes, because it may be represented two different ways. Here's X. So I am going to draw my FABX. And you know it has to be parallel to the X-axis. For me to draw things parallel, I need to turn my paper. So I'm going to turn my paper. So here's my force ABX, and it's positive. Now, force AB, where are we? Let's see. Angel. Angel?
Yes.
Okay, force AB in the Y, is it negative or positive?
Force AB in the Y.
Yeah.
That should be positive.
Take a look at the value.
Oh, no, that's definitely negative.
Okay, that doesn't make sense. Okay, so you're right by looking at it, it's positive. Did I give you the wrong number? Maybe I gave you the wrong number.
I have it written down as positive 500.
Great,
from the
thank you. Good job, Angel. Yes. You were checking yourself with the picture. Okay, force Y, is it positive or negative?
Force Y is positive.
Positive. And it's coming from point A, right? So I'm drawing force AB Y in the positive direction. And now Bon, what about the Z?
The Z is in the negative.
The negative direction for Z. So again, I'm looking at the direction. Everybody look up here. I'm looking at the direction of Z, and I'm drawing a line parallel to Z. F-A-B-Z. Okay? And those of you who took graphics or went out and bought one of these things, you could do it. X, X, Y, 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 sorry, Y, Y, Z, Z. Okay? And actually, my X isn't so perfect. So I'm going to draw it a little bit better, but I did it in a Sharpie. That's all right. I'll just do this. Just make it thicker over here. Okay. And now, Colin, what am I trying to find the moment about? What did we say we were finding the moment about? Colin? Okay, next. Daniel C. What am I trying to find the moment about? Is everybody taking bathroom breaks? Okay.
No, he's here.
Oh, Daniel C, where are you? Okay. No, I think he might be stepped out. Okay, Daniel H, you here?
Yeah.
Okay, so Daniel, what am I trying to find my moment about?
Moment about C.
Point C, right. So that means I'm trying to find the moment about the x-axis through C, the y-axis through C, and the z-axis through C. You agree? Because I'm trying to find the x, y, and z component of the moment about point C. So something I really need to make sure that I'm doing is, everybody watch what I'm doing. I'm drawing the z-axis through C, and I'm drawing the y-axis through C. And in the end, I'm going to cross these guys out so I don't get confused and use the wrong axis. I'm trying to find the moment about the x, y, and z axis about point C. So why, Daniel sees back, why am I trying to find the moment about the x, y, and z axis through point C?
Can I skip this one?
Sure. Daniel, no, it's kind of a crazy question. The point is, that's what I'm asking you to do. The problem is to find the moment about point C. So you have to find the moment about the X, Y, and Z axis through point C. And I cross these other guys out because sometimes my eye goes to those and I don't want them to. Okay? And now what I love is drawing tables. So we're drawing a table.
Your focus went off?
Okay, great. Thank you. And I have to zoom out too. So this is going to be a little bit hard to do. Maybe what I'll do is this. Okay, here's our drawing. Everybody could see that, right? I tape it down. And now I'm going to draw my table. And I guess I have to make the table. Maybe let's do this. Good? Yeah, looks good. So whenever we make tables, and you guys, you're in materials, you'll make a lot of tables. But we're starting to make tables in statics now. In the first column is force. And I have a force in the X, I have a force in the Y, and I have a force in the Z. And it's ABX, ABY, ABZ. And the absolute value of the force in the X is 400. The absolute value of the force in the Y is 500. And the absolute value of the force in the Z is 360. And my force, it's always important to put units. So always put the units at on the table on the top. So I only have to write it once. So my first column says force, newtons, force ABX, ABY, ABZ, ABZ, and then I put the values in absolute value. Okay, then I'm doing the moment about C in the X, moment about C in the Y, and the moment about C in the Z. And the units are going to be Newton millimeters. So clear tables are important. You put the moment, tell them what's in the column, and then the units. So Daniel C., I'm going to go back to you. Without even looking at our picture, we already know something about what moment does a force X create about a moment through the x-axis. Right. No, 0, because they're parallel. So can I go down this line and do this?
Yes, you can.
So without looking at the picture, we already know that the force in the X creates no moment about the X. Force in the Y creates no moment about the Y. And force in the Z creates no moment about the Z because they're parallel. Okay, now we're up to Daniel I. I don't remember if we went to you yet.
Yes.
Okay, did you already answer a question?
Oh, no, I haven't.
Okay, all right, Daniel. So let's look at force X. You see where force X is here? Force X is here, and here's the Y-axis. Can you tell that force X is on the top of the box coming out at us, and force Y is on the bottom of the box going to the right?
Yeah.
Does force X create a moment about the Y? Does this force create a spin around the Y-axis?
Yeah.
Yes. So we know there's a moment. Is it a positive or a negative spin? Fingers go in the direction of the force. Palm goes down towards Y. Do I get my thumb in the positive or the negative Y?
Positive Y.
Great. So it's positive. Okay. The absolute value of the force is 400. What is the absolute value of the perpendicular distance, Daniel? I still.
Oh, would it be 180?
Yes. Awesome. And it is 180 as a check. If you can't see that it's 180 as the perpendicular distance, the check is the force is the X, the moment is about the Y. So the distance, the perpendicular distance has to be in the Z. Okay. David L. So now we're looking at the force in the X. Does it create a moment about the Z? Remember, we're looking at the Z axis through C. Does it create a moment?
Yes, I believe the force in X will create a negative direction Z.
Great. Okay, and the absolute value of the force in the X is 400. The absolute value, so now what is the perpendicular distance from force X to Z?
Right, so because it's an X force and we're looking at the Z axis, we need the Y distance, so that's 250.
Excellent.
250 millimeter.
Okay, I'll multiply them at the end. Okay, now we're up to David LR. David?
Yeah.
Okay, so force Y. Now we're looking at force Y. You see where it is?
Yeah.
It's on the top of the box to the right, and we're trying to find if it creates a moment about X. Does it create a moment about X through C?
It does.
Yes, great. Positive or negative?
Negative moment.
Negative, right. Absolute value of the force is 500. What's the absolute value of the perpendicular distance?
180.
Yes, great. The force is in the Y. We're trying to find the moment in the X, so the distance has to be in the Z. Equals. Okay, Edgar, you're on. Does the force in the Y create a moment about the Z axis through C?
Yes.
Okay, good. Positive or negative?
Yeah, this is kind of hard just to check. Hold on.
Fingers go in the direction of the force, palm goes towards the axis.
Okay, I'm trying to see. It's kind of hard for me to have it.
Yeah. So let's make it bigger then, huh? Here's force Y. It's on the top back line. And here is force Z. It's in the middle on the left side. Is there a perpendicular distance between the two?
Yeah, there is.
There is. And can you tell what it is?
Yeah, it's 100 millimeters.
100 millimeters, right. So, oh, sorry, I didn't ask you. Positive or negative?
Yeah, that's
Fingers,
the-
what?
Yeah, that's what I'm trying to see. Cause,
So fingers go in the direction of the force.
uh-huh.
Palm goes towards Z. Is your thumb pointing up or down?
Down.
Down, so it's negative.
It's negative. Yep.
500 times 100 equals. Okay, Elizabeth. You here? Okay, Eric.
Hi.
Hey, Eric. Okay, next one. Now we're looking at force Z. Does force C create a moment about the x-axis through C?
Yes.
Yes. Positive or negative?
The negative?
Negative, right. So let's do that one. Here's force Z, right? And here's the x-axis. It's causing the x-axis to spin. The direction is going down of the force, right? So the force is going down, my palm goes towards x, and it's a negative. So the absolute value of the force is 360. What's the absolute value of the perpendicular distance, Eric?
Is it 250?
250, correct. Because the force is in the z, the distance, the moment is about the x, it's the perpendicular distance has to be y. And Gerardo.
Hey.
Hey. Okay, so does the force in the z create a moment about the y-axis? Where's the y-axis? Here.
Yes.
Right. And does it create a positive or a negative?
Negative.
Negative, correct. You guys look, the force in the z is going down in the back, and the y-axis is here in the middle. This pink is going behind it. Fingers go in the direction of force, palm goes towards the thing, and it comes out to be going in the negative y direction. Absolute value of the force is 360. What's the perpendicular distance, Gerardo?
250.
Try it again. The force is in the z. The blue line is in the y. The distance has to be in the x. The
Oh,
pink,
180. Yeah, sorry.
the pink is in the back. The blue is in the middle. What's the perpendicular distance?
180.
100. Okay, let's try it again.
Hey.
Gerardo, look. Force is in what direction? The pink force is in the
No white
D.
Z, yeah.
The blue line is
Y.
in the Y.
Yes.
The distance has to be in the X. Here's the X. So it's either this 100 or this 100 or it's 200. It's 100. Okay, now we add up all the numbers.
Joanne, I have a question,
Yeah.
a quick question. So,
Yes.
I'm not sure if you explicitly said it, but for this
Yeah.
method, you have to put your axes on the point you're talking about because of right-hand rule facing those axes.
Correct.
Okay.
Because you're trying, the question says, find the moment about point C.
Right.
So that is it. We have to find the moment about point C. And what you're trying to do is find the X, Y, and Z components of the moment about C. So you have to draw the axes through C.
Okay. Just checking that
Yeah.
that's mandatory. You have to have your axes at
You have to.
Got it. Okay.
Right.
Thank you.
Because you're finding the moment about C. If I did the axis at D, I would be finding the moment at D.
Yeah, and that might change which way your palm is facing because of where things are
That's
positioned.
correct.
I got it.
Exactly. So mark up the page big where you're trying to find the moment. Okay, so what do we get? We got 400 times 180, 72,000. This is probably, is it 100,000? It's 4 times 25. This is a negative. I should just check it. 400 times 250 equals, yeah, 100,000. And then 5 would be 4 zeros. 500 times 180, negative 90. 360 times 250 equals negative 9. Oh, sorry. This would be 36 and then 3 zeros, negative. So negative 90, positive 72, negative 36, negative 100, negative 50. Okay, so now we're going to sum it all up, right? We got negative 180,000. We got positive 3600. And we got negative 150. So my moment about point C is negative 180 I plus 36,000 J minus 150,000 K, and the units are Newton millimeter. And now I'm going to check it. Yep, I got the same thing. So when we got this, we solved for the moment about point C vectorially, R cross F, and now we did it with the right-hand rule. Certainly, doing it by the right-hand rule is longer. It takes a little bit longer, but you're understanding the feel of what is actually happening. What is happening to this point due to these forces physically, okay? I'm up to Hyoji. Hyoji, in this case, we found the moment, we express the moment in vector form, but how else do we express moments? What's the other way to represent them? Maybe she's not here. Isaac? We express the moment in vector form, but we also express moments in what's the other way?
Magnitude and direction angle.
Magnitude and direction angles. And we've already calculated them before. And then, Jack, once we get our direction angles, what are the two checks for direction angles? Jack?
I think it's squaring the cosines of them.
Right, the cosine squared equal 1, and?
I don't really remember the other one. Is
Okay.
it related to the angle? Is
Yes, yes.
Yeah, I don't really remember the other one.
Okay, if you have a pause, okay, look at this. We have a negative moment in the X.
Yeah, the plus or minus visual.
Well, it's really called acute or obtuse,
Yeah.
right? Because we have a negative X and a negative Z, I should get an obtuse angle. Okay, I'm gonna stop sharing. Does anybody need to still copy something? Okay. Okay, you guys, how do you feel about 3D right-hand rule? Okay, so let's go to, I'm going to share the screen. And for today's module, Thursday, October 1st, here's the overview. Here are the two problems we just did. I'll put the Zoom recording in, of course, and then you have a homework. But let's take a look at the overview. So in this module, you will learn how to solve for moments about a point due to a force in 3D space using right-hand rule. What you will learn by the end of this module, you will learn 1, a force cannot create a moment about a line it is parallel to. You'll learn that a force cannot create a moment about a line that it intersects. And you solve for the moment about each axis through the point due to each component of the force using this table. And then you express the moment in vector form. Let me edit that. In vector form and in magnitude and direction angle. And lastly, you check your direction angles by 1, cosine squared function. Can I just say cosine squared equals 1? How about, you know, it's so difficult on these things to do all the math stuff. Sort of equation. The sum of the cosines of the, let's say, direction angles equals 1. And the second one is the acute obtuse check, which means if the force component is negative, direction angle should be obtuse. Let's say if the direction angle is positive, save that. And then read it better. Okay. Force can't create a moment about a line if it's parallel. Force cannot create a moment about a line if it intersects. Then we're solving for the moment about each axis through the point. You're trying to find the moment about to each component. So you look at each component of the force and you find out what the moment is. And notice I wrote units up here. And then you express the moment in vector form and in magnitude and direction angles. And then you check your direction angles by the sum of the cosine of the direction angles equals 1 and the acute obtuse check. Okay, I'm going to stop sharing. I got done early today. 15 minutes. Woohoo. Okay. So now I have,
Joanne, I have a question.
yeah, hang on. I have a question too.
All right.
For you. Let's let Angel ask his question first. Angel.
I like this method with the right-hand rule. It seems really nice and methodical.
Yes.
But let's say, since we're always thinking of like truss bridges as like the ultimate example, if we're using, if we're solving for forces with moments with truss bridges, we want to use the vectorial version or the right-hand rule version.
We're gonna wind up using right-hand rule from the rest of the semester.
Okay.
We're never gonna use vectors ever again.
Oh wow. All right.
Cool. We're gonna do right-hand rule all the time in 2D and 3D. Always.
Right. Sounds
because
good.
that gives us more of a physical feel. When you're working with a team of engineers and you're designing something, you need to know by looking at it what moment is created about where, due to what forces. You don't want to sit down and start doing R cross F. You want to really get a physical feel for it.
Okay.
Okay?
Cool.
All right. How comfortable do you guys feel about this? 3D right-hand rule. So the question I have for you is tomorrow in lab, Rob is doing 3D right-hand rule, more problems. Do you want to do more problems in 3D right-hand rule, or do you want to have a review overall of everything we've done so far? For instance, when I'm looking at you guys doing the statics of particles problem, I still see people not being able to draw in free body diagrams in 3D. I'm also seeing people not comfortable with free body diagrams. They're keeping connections there, or not putting the axes in, or not labeling, or not putting in distances. So I'm seeing, and I'm also seeing problems with people having problems about finding components of forces giving distances, which I'm really troubled by, because that was homework you did in the summer. That was 5 weeks ago. And as you're noticing, everything in statics is building up on each other. We're in week 5. We have time to catch up right now. But in 2 weeks, you're going to be screwed if you do not know the stuff in the past. Okay, and again, you're supposed to be putting in 10 to 15 hours a week on this homework, on this class, right? And I don't know if you are or not. And I know we have COVID and we have fires and we have all this stuff going on in life and your kids are at home. You know, I know there's so much stuff going on, but you got to stay on top of it. And if you're finding that you have too much going on, then you need to drop something and take the class that you want to stick with. If you feel like you're totally behind in statics, drop statics, take it next year. But if you're behind in physics or something else, drop that. If you can't handle all the load you're taking right now, don't do it. And let me tell you, there is discussion at Cabrillo, and it is quite possible that next fall is online. Are you hearing that? Next fall, it's almost positive that it's online. So you can't say, fuck it, I'm not going to go to school this semester. I'm going to drop everything and I'm going to come back to school next year when everything's in person. It's not going to be in person. Next spring of 22 will be in person. But right now, the college, the college is asking us to plan doing fall online next year. So this is it. This is what you're going to get this year and next year. So if it's too much, drop something. This spring is definitely online. This spring is definitely online. Summer is definitely online. And almost definite is fall of 21 is online. You know, don't worry about being in school another year. By spending more time on the courses, you are learning so much more. As it is, when Cabrillo students transfer, you know more than the students who came in. And I'm telling you, I know because I saw how statics and materials and dynamics were taught for my son at the university that he went through. It was breezed through. There's no way in hell they all learned that stuff. You guys are learning so much more. You're going to be so much more competent engineers. So I much rather you learn the material than fly through. And you're young. Okay, so I'm not trying to scare you or anything, but I just want to be a realist. Next fall is almost definitely going to be online. So you have to think now, are you taking too much? I will say that if those of you who are taking 4 demanding classes, you're crazy. You're taking 3, you have to figure out whether that's going to work or not. But I do want to tell you that the machine shop class where many of you are waiting for, in the spring, 2 sections will be offered and it will be in person and online. So you will be able to take the machine shop class in person. And in the next fall, it'll be the same. Okay, what questions do you have?
Joanne, just to circle back here, a lot of the chat says we should probably review. So I don't know if you were seeing that,
thank you.
but,
I didn't see that.
Lots of people chimed in saying maybe for Friday should be a review.
Okay, because if you're feeling pretty comfortable about the right-hand roll in 3D, then we don't need to do the 3D tomorrow. But I know you just need practice. Hang on a second. I want to show something again. This problem is easier than this one. And the reason why is because I already drew all the forces. The forces were given in the X, Y, or Z direction, right? All the forces were given in the X, Y, Z. So this is where you got comfortable figuring out the moments, the spins about the axes. The hard part about this is you are only given the direction of AB, the total resultant of it. You have to draw the X, Y, and Z components of it, and you need to draw the new X, Y, and Z axis about the point you're finding the moment about. All three of the homework problems are like this one. They're harder. You have to draw the forces going in the direction they're going in, and you have to draw the axis through the point. I think what I'll do is I'll post the solutions for this. So when you do the first problem, you could look at the solutions, and do the second problem, do the solutions.
Joanne, for
Yes.
the homework problems, would this be like what you have up here? Would this be like considered an okay diagram for the homework?
This? Yeah, because we're not drawing free body diagrams for this problem. You know, we're just, but I think, you know, so what I think I am noticing is that some of you are not drawing 3D diagrams. What you're doing is you're cutting and pasting the pictures from the textbook onto your homework, which means you have not had practice drawing in 3D. So every time you could draw something in 3D, you should do it, unless you're a pro already. So Tony, to ask your question, yeah, this is all you need. This is not a free body diagram. This is not a statics problem. We're not doing free body diagrams. We do free body diagrams in statics problems. This is just a problem to calculate what the moment is about point C due to this force going from A to B.
Okay, thank you.
Okay, so do you guys want to do a review tomorrow then from 8 to 10? Yes? Okay, so I just have to cancel a couple of meetings and I'm gonna run it and give Rob the day off. Okay?
Solid.
Okay. All right, I'm letting you out 5 minutes early, which means you just got, I still only owe you 30 minutes.
Deal.
Okay, so I'm gonna be on for a while if you have questions. Otherwise, I'll see you at office hours at 1. There are no interviews today. I still have interviews tomorrow, and then some of you still have not filled out the interview survey. Okay, you guys are crazy. Those of you who have not filled out the interview survey, you're crazy. Look at my modules or look at the calendar and look at all the things that are due. Get them done. Okay? All right, so I'll see everybody tomorrow at 8, and I'll see those of you I'm interviewing tomorrow when I'm interviewing from 2 to 5, and then come to office hours today from 1 to 2. Otherwise, you guys could take off, and I think I'm gonna stop recording, or no, I'll probably leave it on because sometimes you guys have good questions.
Okay, thanks, John.
Okay.
Thanks, Joanne.
Yeah, Luis just said he wants a review of the last 5 weeks. So I'll start out from the beginning and go through everything we need to know. All right?
Are you gonna post the solutions to homework 12?
All right, I'll do that right now. Thank you.
So on the subject of homework 12.
Okay, hang on. I just posted the homework solutions for 13, and now I'm posting the solutions for 12.
All right, I'll look at that before I ask my question because it'll probably answer it.
Okay, great. Thanks. All right, I'm coming back to
Hey, Joanne, I had a question.
yes. Yeah, let me get back to the screen. Okay, I could see you now.
Okay, it's
Is that
from the
Luis?
interview.
Yeah.
Yeah. I got your message, but it was at 5 o'clock last Monday, and I work at 5 o'clock.
Yeah. What are you talking about? What was the
I think the interview.
Okay, that's fine. So did you I think you put your things down on the right?
I did, but then I saw that you messaged me. We can talk about it in office. I'll stop by in office.
Oh, okay, sounds great. Good, thanks. Some of you wrote down that you're just available on Friday, and that means I was already booked for this Friday. So if you could go in and give me other times that you're available, that'd be helpful. Okay, what other questions you guys have?
On the survey, it was just it just gave this week
All right.
when I
Good point.
I mean, we could just
You know,
go in and-
just answer them as if it's a Monday, Tuesday, Wednesday. Don't worry about the dates.
Okay.
Okay, thanks. Yeah, a good point. Just answer it because it's kind of the same. My weeks are usually the same with there's some exceptions, but. Okay, what other questions, you guys?
On the second statics, the particles quiz,
Yes.
I put for find. I noticed that you circled the forces that we needed to find in my table, and then you drew an arrow up to the
Okay.
find section.
I'll have to look at it. Do you, are you free, Maria, today at office hours so I could do that individually or no?
Yeah, that's fine.
Yeah, 1 to 2. Yes?
Yeah.
Yeah, it's easier to do that individually because it's only on your quiz.
Oh, I emailed you the PDF, by the way.
Okay, thank
Have you
you.
noticed whether, I don't know if I've submitted anything else since then. I think I submitted homework 11 after that.
I'm a little behind on grading.
Yeah, no problem.
I mean,
I've been
grading
submitting.
online is a pain in the ass, but learning online is a pain in the ass too. So sorry, we're all
Yeah,
dealing
it's all
with
good.
this. So yeah,
Yeah.
I think I'm behind 2 homeworks and another quiz. Quiz
Are
on
you-
Tuesday.
This is a weird diagnostic question, but are you able to open Jordan's submissions? Because we use the exact same app and technology to upload.
Yeah, I am.
Okay.
But let me check. Yeah, Jason, Isaac, you're coming at 1 to 2 today or no? Maybe
Yeah,
not?
I'll probably come in this
Okay.
afternoon.
Okay, so I could look at it then. I mean, I could open it now and see if I could. Okay, I just got the quiz. Okay, yeah, I see it. I don't know why it wasn't.
Oh, it's
able to
opening in
open before.
Canvas now?
No. I'm looking at the email.
Oh, okay.
So I have
Okay.
no idea why.
I just want to, like, if that's going to be a consistent problem, I'll just find it. I'll just upload them the way I used to.
Okay. I could check later though from 1 to 2. I
Okay.
just made sure that I can actually get your email.
Sweet.
Okay. What else, you guys? What other questions?
I have a question about filling out the survey. So it
Yeah,
says
Angel.
from what excuse me, from what hours to what hours, and I'm trying to fill in from an hour to an hour, but it says it doesn't allow me to like place a dash.
Okay, then why don't you
Lots of
say
spaces.
2, 3, 4, 5 or something?
All right, let me see if it allows me to do a comma because it says it has to be a number.
Really?
Yeah.
Okay, so just write 2, 3, 4, 5.
Oh yeah, the first field, there was an issue. Yeah, because you couldn't put a space. It was like from what time to what time, and you click 11 and 1.
And I put
Because it was like,
11.
oh, this field must be.
Oh, all
I
right.
put
Let me,
11, 2, 1.
okay, let me,
That's clever. Yeah, fine.
all right, let me open up the drive.
Then she might think it was 11:21 that you wanted to meet.
Yeah, I just wanted to like confirm that with
The
you.
type of question I chose was that you could fill in the blank, but maybe it,
I think it's just the top one, like the Monday 10 to 1.
That's right. I only had that problem on that one, and I used spaces and other characters in the other ones.
I chose all short answer questions. So why, let me see let me open it up. Short answer.
Joanne, if I put 11 to 1, like 11 to 1,
Did you put in the first one?
Yeah, would that be clear? Like that I'm
Yeah.
free 11 to 1?
Yeah, 11 to 1.
11 to 1, okay.
Yeah. Oh, wait.
Wait.
I picked, no, yeah, go for it. I'm sorry. Talking to
Okay.
myself. Yeah, it says short answer text, but then it says a number. Okay, it's right now. Is that the only one that was a problem?
Yeah, that was the only one.
I hate when computers are trying to be smart. I'd rather them just listen to me. They're like children. They can't just listen to me. Okay, good. All right, what else? I met my own children. You guys aren't children. You know that. Okay, Maria, question.
I'm working on, I just completely missed the second part of the setup quiz. So I'm working on the free body diagram of them both together. It's both of the balls. It's the barrel one where they're next to each other.
Oh, okay, okay. But remember, you could resubmit it for more points, right? So I can't really talk about it.
Oh, okay.
Right?
Okay.
So remember, it's a free body diagram, right? So whenever you remove, when something's touching, Maria, look at me. When something's touching, when you remove it, you have to remind it that it was touching something, right? So when you have a normal, when you draw the free body diagram of the eraser, you have to remind the eraser that that surface was still there, and you have to draw a normal. So when you draw the free body diagram, you're drawing it only of the eraser. But you have to remind it that it had other loads on it.
Yes. But when they're stuck together, then they're just, when you cut the eraser in half, but you have it still together, then it's just one eraser.
Right, so when you have the two cylinders together, when the two cylinders are together, the force in between them is an internal force, and you don't draw them, because if you drew them, you would draw both of them and they cancel each other out.
Okay. I think I have the right, I think I got it. Thank you.
Okay. Any other questions?
Question on my submittal of my particle quiz 2.
Okay, so it's the same. Wait. You mean the setup, right? The setup quiz 2, yes.
Yes.
Right, okay, because it wasn't the whole, okay, yeah, setup.
So the question is, did you get it?
Why, did you not get anything? Did you not
Correct.
get a grade?
It says missing, yeah.
Oh. Okay, let me look.
I ended up emailing it to you because the time that you asked everyone if they could do.
Yeah.
Yeah, that.
Okay, so let me look.
So I emailed it to you.
Yeah. Okay.
Basically later that day.
Okay. So yeah, if you emailed it to me, then I got it, but I didn't look at it. So let me check. So did I just tell you to? Yes, that's right. I did say to email me, right? Okay, so hang on. Okay, I got it. Okay, so I'm gonna print it out. Okay, thanks, Jason. Sorry about that.
Yeah.
Okay.
Joanna had a question about just in general. So
yeah.
sometimes,
Okay, wait. Let me come back in to see you guys. Okay.
sometimes when I look at your solutions, just the way you round off versus the way you round off,
okay.
I get 1 or 2 magnitude difference.
Okay. So okay. So initially, when we started this class, we had a rule that when you represent the vector form of the forces, we have 1 decimal place more than the given answer, right?
Right.
Okay, so that was the rule that we followed and we were all like right on. Now we're doing moments and we're multiplying forces by distances. So I'm not so concerned about the decimal place. I don't want to see 4 decimal places, right? But you could round off and you're fine.
Okay. Sometimes I get a different answer and I get the comment to check your answers, which I have, but I just rounded off a little bit different. So I was just, I'm
Okay,
like,
so is that on the quiz?
no, in the homework.
On a homework.
Yeah. So
Isn't that just something that you copy and paste onto all of our comments is check my answers?
Yes.
It's not directed at us specifically.
Right, because I'm not checking for, right. I'm not checking that you got the right answer. I'm checking how you're doing the problem, the setup. So in the end, I want to make sure that if I got 20, you got 20.
Okay.
You didn't get 40. So if I have 20.1 and you got 20.2, it's totally fine.
Okay.
Okay?
And then also with the free body diagram with the quiz question, when you have the 2 bodies and you said to draw them as one, I put the body and then I labeled it that it was A and B, but I put it in a circle.
Okay.
And you made a comment to draw them separately still.
Okay. So did you, I'd have to look at your quiz, but did you make it so that both point A and B are on the same point?
Yes.
Okay. So you can't do that. So what's happening is, remember, we're transitioning now from statics of particles where we have one point and all these forces are on the one point. And when the forces are only on one point, the only thing that could happen is translational motion. There can't be any rotation. But if I put two bodies together and there's a force on this body, it could cause this body to spin because now there's a distance. So we're transitioning from static of particle to rigid bodies.
Static of particle quiz though.
I know, but
So
I also,
statics. It was static, so I just assumed that.
yeah, they have to be, you have to draw the free body diagram with 2 cylinders with the weights off each one.
Okay.
Okay, and we did a problem like that. Hang on.
I got confused in the wording because I was kind of looking at it for a long time and I was like, it says as 1, so I just drew it as 1.
Okay, so hang on a second. Let me just show you a statics of, I might not have all my handwritten, I just keep what's neat and I throw out the rest. But let me just,
office hours.
No, just hang on a second. Let me just, I can't find a problem, but we looked at a problem where we had to draw 2 different free, oh yes, I remember now. It was a setup problem. It was this problem where we had a weight off a cable and I'm sorry, we had a force on the cable at this joint and we had a weight here, and we determined that there were 4 unknowns, so we had to draw 2 bodies. So we went ahead and drew 2 separate bodies.
Yes.
And then on the side, I said, okay, you guys, now draw a free body diagram of this wire. And when you drew a free body diagram of that wire, you did not include this tension 1 anymore. You had this tension on it, you had this weight, you had this load, and you had this tension. And in this case, you were drawing a free body diagram of a rigid body.
Right.
So we had one example in class.
Yeah.
The main thing is one quiz or one homework is not gonna substantially impact you. The point is to learn it. So now you know that it has to be separate. And it could be that many people, now that you're sharing this with me, many people may have combined A and B, but you can't combine A and B.
Yeah, I might have made that mistake.
Okay.
So always draw it like the body how it is what you're saying.
Well, when you're drawing the cylinder A, when you drew the cylinder A, you just have to draw it as a dot. And cylinder B, draw it as a dot. Because all the forces went through that dot. But if the forces don't go through the center, you have to draw it as a rigid body. So that'll be something we go over tomorrow, I think.
Yeah, I just want to make sure that in the future I don't make the same.
Right. Yeah.
Then,
So now when you do it again for the resubmit, you'll get points back.
okay, and then for the normal force,
Yes.
you need to indicate the force that the object has on the wall.
You need to basically, Laura, you know the thing where, like if you and I were standing on the ground, right?
Right.
And you and I both put our hands out, right? Put your hands out. Like if you were standing up and I was standing up and we both had our hands on each other, right? And we were leaning in. If you took your hands away, I'd fall, right? And if I took my hands away, you would fall. So we have to remember that when we draw a free body diagram of you, just as a free body, we still have to put the normal from me on there. But we removed you, but you fell. So you still kind of have to account for feeling that load.
So in the free body diagram, I include the force that I'm feeling if I'm drawing it on me, but I don't include the force that I am causing on you.
Correct.
Because I'm like free.
Correct.
Okay, so that's kind of where
Yeah. So tension might be pulling on you. You got to draw it. Gravity is pulling on you. You got to draw it. Pushing on you. You got to draw it. You're drawing a free body diagram of you and how you are being impacted.
Okay. So that's kind of also is that I drew like a normal force that was the force was impacting on the wall and I wasn't supposed to do that.
Right. You're drawing a free body diagram of you and what is impacting you.
Got it. All right. Thank you, Joanne.
Okay, you're welcome.
And maybe I'll see you at office hours.
Okay, or tomorrow. Hey, Jason, I think you've been waiting for a problem.
Oh yeah, you want to see thing?
Yeah, hang on.
This is
Okay. What are we looking at? 321
Well,
homework. Let me close this binder.
So the first thing I did.
And is this moment about a line? I'm sorry, because I don't know the numbers. Okay. Moment about a line. Okay, and you're on 321. Okay.
Yeah. The tree. I just wanted to run this by you and see if you liked the setup and
okay.
If it's clean and professional to you.
Got R, great. Label what the R is from and the R is from and to because it's a vector, right? Oh, there it is. You're showing it in the picture.
Yeah,
okay.
Yeah, I showed in the picture, but you're right.
O
This
to
could
A.
say
O to A. Okay. Okay.
I started by importing the moment.
About 0.0, good.
About 0.0. By the way, when I did that problem, what I did is I combined those two vectors.
Great.
I just added them.
Yeah, the two force vectors, right?
Yeah.
Totally great. That's what I did too.
What I could have done instead was find the moment due to each vector individually and then add those vector moments.
Right, but that would have taken longer.
Exactly, that's what I said. Okay.
That's why the statics books want us to learn how to solve resultants first before they teach moments. So that you'll do the resultant first and then the moment.
That's what I thought. So then I drew an abbreviated diagram, if that's all right.
Yeah.
Yeah, some extraneous stuff. I made a mistake, crossed it out, and then tried again with MOA.
Yep, you got it.
Sweet.
Yeah, so moment about OA, I'm just looking at the equation up top. Moment about OA is equal to the moment about O dotted with the EOA. Great. Oh, you know what? That .1240 is not an R vector, it's an E vector. Go up. Up, 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 there. That's an E vector, right? Not an R vector. The R vector is the numerator of that. That is the unit vector.
This is wrong.
No, no, that's all correct, but it's where you say ROA, it's EOA.
This should be EOA.
All the math is correct. Just where you have the ROA, cross out that R, right? And it's an E.
Yeah.
Correct?
Yeah.
And then you go down now, please.
Okay.
-12. Yeah, you use the E, right? The
Yeah.
equation at the top says MOA is equal to MO dotted EOA. And then you proceeded to find EOA, right? You don't need ROA at all.
Well, I guess.
You could do it if you want. You could write it
for-
if you want, but we've always just wrote unit vectors by dividing the X distance divided by the total distance and the Y distance by the total distance. Right?
And just to make the point about the difference between these two, because you're right, I did say R, and then
Yeah.
that was not actually correct. The E.
Right. But the only thing you really did is you wrote R instead of E because you found what you really needed and you used what you needed. You plugged in the
I really only need to do this line.
Right.
And I did notice that because I did notice that this wasn't R, or at least it wasn't an actual distance. Like I couldn't use a ruler to indicate E because it's unitless. It's a direction.
Right. That's right. There's no units for E. Correct.
Yeah.
But on the picture where you're showing R, you probably should write ROA, and that is the same direction as EOA, right?
Yeah. Oh yeah.
Yeah. So, and you could write EOA there too.
I was thinking as we were going along, I was thinking, your comment about how sort of the diagonal of your table, and your comment about how well these two, it has to be 0 because they're parallel. I find that misleading.
Okay, how come?
Well, because they don't need to be parallel. If they're parallel, the implication is backwards, right? So if they're parallel, it implies that they're in a plane. And if they're in a plane, there's no moment on the line. But they don't need to be parallel. They could be at any angle to each other. It's just that parallel implies that they must be on the same plane, and thus they must not have a moment.
Okay, so let me try. Yeah, thank you for pointing that out. Let me just show.
Because people are going to start thinking if they're, they need to be parallel for there to not be a moment, and that would be misleading.
Okay, so let's see. Let me see if the presenter will still work.
Because there was another time on this diagram where you pointed out, look, they're perpendicular.
Well, not perpendicular, intersect. I made a mistake when I said that, right? I corrected myself.
Oh, I didn't. Okay.
So in this particular case, okay, to start out with, I think that students are comfortable seeing that this force here is parallel to this axis, right? The orange FX is parallel to the x-axis.
Yeah.
And when two forces are parallel, they create no moment.
Yeah.
I want to just go there for a minute. Just hang with me.
I'll hang with you.
And then we had a problem where this force in the x intersects the y axis.
Okay.
So because they intersect, they're 0. And then we could and then we could extrapolate and say that on a plane, two lines either are parallel and they never intersect, or they intersect somewhere on that plane. So what I can do is say, if two forces are on the same plane, there's not going to be a moment. But I think from my experience with students in statics is that two things on the same plane sometimes is hard for them to visualize, but they can visualize when two things are parallel or they intersect. So I am saying that mathematically, one force vector cannot create a moment about another line if they're on the same plane. That's correct. But I think students understand if they're parallel, they don't, or if they intersect at some point, they don't. So I'm not trying to be misleading.
Of course not.
But I'd like to stick with this force is parallel to this line, so it's 0 because of that. There's going to be a homework problem. There's going to be a homework problem where this force intersects this line. So since it intersects, there's no moment. And I want to continue to just talk about it in terms of intersection and parallel. But I realized that, you know, David Leopold with a degree in math, and you also with a little more depth knowledge of math, both understand that, Joanne, what you're really saying is if the force is on the same plane as the line, there is no moment. And yes, that's true, but not everybody understands or can see a plane.
Well, we're here to practice, aren't we?
I rather worry about other things and just have them know that if it's parallel or intersects, it's 0.
Okay, well, so what about for my work? On my work, I would prefer to put some kind of symbol that we both agree means that they share a plane, because that's fundamentally.
Sure. That's totally fine with me, Jason. So just write 0, same plane.
Okay.
Yeah. Or if you want to come up with a plane draw, you know, your representation of a plane, or if there is a representation of a plane, great.
You taught GD&T.
Yeah, but a plane. Okay, let's look at this again. Hang on. I mean, we could call this, you want to just say this is a symbol of a plane?
Okay, so check it out. I got that wrong on the, what was this? The Oxford interview.
What the hell is an Oxford interview?
Well, it's an interview with Oxford Instruments.
Oh!
They asked that question, Joanne.
What did they ask?
They said a GD&T symbol is a parallelogram. What is this indicating? I blew it.
What is it? Is it a plane?
No, it's actually, no. Well, that's what I said. I
have
said
no idea.
parallelism. I said, you know, it's a specification of parallelism, you know, and it has a 0.03 next to it as well. It's like how parallel these two surfaces or lines are per, you know, per inch.
Wait, so you said, okay, is their answer they wanted to hear plane?
No, they said surface.
A surface. Well, is a surface a plane? A surface can be round.
It's a surface specification.
All right, well, whatever. I don't know.
To say like yeah, it's it means that the surface is, it's like a flatness surface quality specification, like no deviation greater than 0.03 per inch.
Oh, okay. So they're saying it's a flat surface.
It's a flatness, yeah.
Flat surface. Okay, because the word surface, you could have a surface on, you know, a computer mouse, and the surface is not flat. So you're saying, so they're saying that this means a surface plane.
Yeah, so it's the quality.
It's a flat plane.
Yeah, I guess it's the quality
of flat surface. They're saying it means flat surface. Well, I think plane is right too. A flat surface is a plane.
I don't know.
Okay, well,
okay, all right. Well, you know, maybe I'll do some more background, but I think between you and I think we would understand that if I drew that parallelogram symbol, we would understand that I'm putting 0 because they are in the same. Yeah.
Correct.
All right.
Okay, great. Thanks.
Cool. Well, maybe I'll catch up with you at office hours.
Okay, I have to go. I'm meeting with Carl now.
Okay.
Okay, bye, Tony. See you later.
All right, take care.